In this video, we're going to have a look at correlation and what that means and how it can be applied. So in this, using correlation, we're going to look at scatter plots, and we can see we've got two examples here. One that looks like it's going up in a straight line, and one where it looks like it's curved a little bit. So in the first example, we're saying weight is dependent on height, but the profitability of a sports store where the profit is often dependent on the amount of advertising done. So we can see that one is a linear model, linear meaning line, means a straight line, where the second example is non-linear. It can only be successful up to a certain point. So when we're looking at these, we are looking at linear graphs, something to remember. A linear graph, like you would have seen back earlier in your schooling, we have an equation of a line, and you might have seen it in the form y equals mx plus c. When we're looking at examples, we're going to use y equals ax plus b. Exactly the same, but slightly different. So we can see that we have a linear graph and a non-linear graph. Correlation is the relationship between two variables. So we saw the relationship before about height and weight. Might be another example of height and shoe size. So something that is dependent on the other. When we look at this relationship, we can discuss the strength of it. So as you would expect, if we had height and weight on an axis, we'd expect to see a pretty close correlation. The taller you are, the more you're going to weigh. When we look at other examples, our data might become more and more spread out. So we use these words to describe it: strong, moderate, or weak. So the closer your points are together, the stronger the correlation. As you can see in this example, all the points are going upwards, so we say it is a positive relationship. Conversely, when it's going down, we say it is a negative relationship, and we still use the same language: strong, moderate, or weak. We use a correlation coefficient to describe the strength of relationships. So if it's positive, we go between 0 and 1, 1 almost meaning a perfect correlation. So here, all our points are in a straight line, so we describe that correlation as positive. Right through to where our points are very spread out over here, so we'd say that is a very weak correlation. And again, when we're looking at the negatives, it goes through to -1 as well. So straight line, negative, and perfect, very strong, right through to very weak. So we have what we call causation. So we don't know that one variable causes the other. So if we look at the example, the age and height of a group of children is measured, and there is a strong positive correlation between the two variables. This will be a causal relationship, because an increase in age will cause an increase in height. Only up to a certain age, of course. So this is what we call a causal relationship. It's a result of the other. We talk about outliers, and it's important to know when we do include them and when we exclude them. So if you have a data point that is valid, it is real, although it might seem a little bit strange, so an extraordinary piece of data, it should still be included. So we use the example of if we're plotting time studied for tests versus marks, and you have someone that has spent quite a lot of time studying for their tests but achieved no marks, well, that's still a valid piece of data. And sometimes it will be unclear whether a piece of data is actually valid. But important to remember that if it is valid data, it needs to be included. So how to calculate it, the R value, we need to use the calculator. So we're going through using our statistics, statistics function. We're going to graph, and then we'll graph our data. Now I've got a dimension error because there's no data there. If I just pop some in, oops. And just some made up data there, and then I'm going to graph it. I can see that it's a positive relationship. Then if I press F1 to calculate it, F2 for X, it gives me a list of values. And my R value is 0.96, and my R squared value is 0.91. And we'll come to the R squared value. So R equals 0.96. We can see that it's positive, so it must be going upwards. It's very close to 1, but it's not 1, so it's not perfect, but we would say it's very strong. Let's have a look at some examples there. So again, if I pop my data into the calculator, 2, 5, 6, 3, and 9, I graph it, I calculate my X using F2, and you can see that I get the following results. So, new chemical on lawn beetles, determine the extent of correlation between the quantity of chemical used and the number of surviving lawn beetles. So here, as you can see, the amount applied increases and the number of beetles, as you would hope, decreases. So we can see that on our graph it's going down, so we know that it must be a negative, and this is confirmed when we look at our A value here is negative, and our R squared value is also negative. Next is to look at the coefficient of determination, which is the R squared. So our Pearson's coefficient is R, and the coefficient of determination is R squared. Now this table is really useful to know and to have in your cheat sheet ready for your tests and exam. It tells you if a range of values lies within a certain range. It gives you the strength of association and the words that you could use to describe. So if we look at the example we've just done, the calculator on the right, our R squared value is 0.73. So that lies in this range here. So we'd say there's a moderate correlation between the amount of chemical sprayed and the number of bugs there. The R squared value is just calculated by squaring the R value. So a study has found that 45%, which is our R squared value, the variation in selling price can be explained by the variation in age of a used car. So if I exit out and go to my main menu, if I took the square root of 45, it would be 6.7. But it's not the square root of 45. It's the square root of 0.45 because it's a percent. So the R value would be 0.67. Now, would you expect that to be a positive value or a negative value? Well, as cars age, we would expect their value to go down, so our R value would be negative.